Hello everyone, this is Sanjit Kumar Singh, lecturer in Electronics and Telecommunication Department at Praveen Patil College of Diploma Engineering and Technology. So, this is the second part of our presentation on fundamentals of fiber optic communication, and in this presentation we'll learn about the construction of fiber optic cable, classification based on the modes of propagation of light and index profile, and thirdly, optical fiber communication system block diagram. After going through this presentation, the learner is expected to imbibe that and describe the construction and features of optical fiber. Secondly, compare working of optical fiber for given mode and index profile. And thirdly, explain the block diagram of optical fiber communication system. So let's see. Here we see the construction of fiber optic cable. So the fibers are mostly made of core and cladding, and the material used for core and cladding is most of the time glass with different doping level to attain or to have the refractive index. So since glass is dielectric material and is insulator, so main fiber with a high refractive index, here the refractive index is the measure of the bending of a light ray when passing from one medium to another. So it is also given as in the refractive index is equal to c by v, where c is the velocity of light in free space for the given light and v is the velocity of the light in the given medium. So typical cable, the coaxial cable will have either 2 or 6 or 12, 18 and 24 cores, and the core could be of the diameter 8 micrometer. 1 micrometer is 1 millionth part of a meter. The second part over that core is the cladding. This layer is also made of either glass or it could be of plastic with lower refractive index as compared to that of core. So this ensures that the total internal reflection at core cladding is taking place and the light is forced to bend itself into the within the core or contain the light within the core itself. When it is plastic, for the cladding it is called plastic clad silica, or it could be hard plastic silica. The third most important layer in fiber optic cable is a plastic jacket that is acting as an insulation and is put over the cladding made of some plastic, typically polyethylene or polyurethane or PVC. So this plastic jacket, outer jacket, is providing the mechanical robustness to the optical fiber cable and protects from the external forces. Then we see the strengthening or tension element as well, that is made of stranded steel or Kevlar. Kevlar is a strong and preferred over steel as it is an insulator, and the coating, that is the buffer layer, primary buffer layer, is it is covering most of the cladding and providing protection, plus added strength and resistance to moisture and damage, and this coating could be of 250 micrometer, whereas cable jacket could be of 400 micrometer. So this is the general construction of a optical fiber cable. Now the classification based on modes of propagation of light and index profile. So this classification, optical fibers can be broadly classified based on a material. It could be glass based or plastic based fiber, or based on the number of mode, it could be single mode or multi mode, and based on the refractive index profile, it could be a step index or graded index. By mode we mean the ray path, light ray path within the core of the optical fiber, or it refers to the mathematical and physical description of the propagation of energy through a medium fiber, or simply the ray paths. So there could be one mode, one path, or could be even 1 lakh paths possible within the multi-mode fiber. So considering the mode of propagation and the refractive index profile, optical fibers can be classified as multi-mode step index fiber, or single mode step index fiber, or multi-mode graded index fiber. So these are the three basic classification. The multi-mode step index fiber, here the refractive index profile of the core is changing abruptly, sharply at the cladding. So N1 will be higher than N2, where N1 is the refractive index of core and N2 the refractive index of cladding. In the adjacent figure we see the refractive index profile. So since the refractive index profile is sharp, it bends the light injected into the core and the light is traveling in zigzag path, and the core is of larger diameter. LED can be used as light source because the core diameter is large and it can gather from wider angle. Light can be injected into the fiber and it is easier to manufacture. So this type of fiber is suitable for short to medium distance and at a low frequency of data rate, and since the light traveling in the center is traveling faster and lesser distance as compared with the light that is traveling near to the boundary, going up and down in zigzag manner. So there is modal dispersion as indicated by the input pulse and the output pulse. Input injected from one end of the fiber and the output the obtained at the other end of the fiber. The pulse is spread as it is traveling along the length of the optical fiber. Secondly, the single mode step index fiber. Here the core size is very small, of the order 2 to 15 micrometer. In general it could be near about 8 to 10 micrometer, and the light injected into it is from a laser source. It requires laser source because the core is of a smaller, very small size, and hence very focused light has to be injected in order to make it travel straight to the center of the core axis, and long distance communication will take place using single mode step index with lesser loss and high data rate, and is used for telephony and CATV with laser sources at 1310 nanometer and 1550 nanometer of wavelength, light wavelength. And thirdly, multimode graded index fiber. Here the fiber core is non-uniform, and why it is called non-uniform? Because it is the refractive index is gradually changing from the center of the core to the edges of the cladding, and size of the core could be 50 to 100 microns and is easier for splicing since the diameter is larger as compared with the single mode step index fiber, and is also cheaper, and very high pulse rate is possible. And this type of multimode graded index fibers are used in LAN, local area networks, and CCTVs. So these are the three basic types of optical fiber cables. Here is the core and cladding diameter given for the single mode and the multi-mode, step index and graded index with the attenuation. So the wavelength, depending upon the wavelength, attenuation is varied. For 850 nanometer and 1300 nanometer, it will be for the generally for the single mode or the multi-mode step index fiber, this wavelength will be used. And for the multi-mode graded index, we have the 1300 and 1310 nanometers used. The characteristics of light transmission through a glass fiber will depend upon many factors. What are those factors? Number one is composition of the fiber. What the fiber is made of, glass, pure glass, or it is ground impure glass. So depending upon the composition of the fiber and the dopant used to have the different refractive index for the core and cladding, the characteristics of light transmission will depend upon. Then second, the amount and type of light entering the fiber. So light entering from a LED source and light entering from a laser source, it will have different intensity and different wavelength. So the characteristic depends upon that, the amount and type of light entering the fiber. Diameter and length of the fiber. So diameter, the thickness of the core and the cladding, particularly the core. When the diameter of the core is more, then it can receive the signal from the LED source easily, whereas when the in single mode, when the diameter is very small, then there we require the laser as a source, and such light pulses will be traveling around the length and attenuation will be taking place within the length of the fiber. So that's why this is one of the factor. Next is the optical fiber communication system. The block diagram, this is of 4 marks, repeatedly asked in the board's paper. The block diagram of 2 marks and its explanation of 2 marks. So block diagram, we see the transmitter side and the receiver side, and in between is the medium, the transmission medium, that is the optical fiber cable. So information could be in the form of sound, data, picture converted into electrical signal. First information is converted to electrical signal, and that electrical signal will be driving a number of electronic circuits which will control the turning on and turning off of the optical source. Now what this optical source will be? It will be the LED or the laser There are different types of LEDs and lasers, and hence their intensity or wavelength radiated is different. So this optical source is converting the electrical signal into light using the LED or the laser. So next is the optical fiber cable, which is serving as the transmission media between the transmitter and the receiver, where light will be traveling in the form of pulses. It is not carrying current like the conventional copper cables. Optical detector is placed on the other end of the optical fiber, where it will sense the light and convert it into electrical signal. So for that, photoconductor, not photodiode, photoconductors are used, and pin diodes, avalanche photodiode, these are the diodes used, out of which avalanche photodiode is faster than the other two and more sensitive. Pin diode is also sensitive, and as it is reverse biased, and light is allowed to fall on the intrinsic layer in between eye. Then we have the electrical drive that provides demodulation of the optical carrier, and there is amplification of the signal as the signal has traveled a long distance along the length of the fiber. There will be amplifiers in between, a regenerative circuit in between, where optical signal will be converted into electrical, and from electrical to back to electrical, from optical to electrical and electrical to optical, and then it will be transmitted after amplification in between using electronic circuits. And destination, it is arriving at the destination as it is converted back into its original form, like sound or data or picture. Here is another block diagram, similar block diagram. This diagram is also valid and explains the same, where we find the electrical input signal and the transmitter section of a drive circuit that will control the turning on, turning off of the light to represent the binary data 1 and 0. And then we have the optical splice. The two lengths of the optical fiber will be joined together using a splicing technique, and in between we see the regenerator, where optical receiver is there, optical signal is converted to electrical, and that electrical signal is processed using electronic circuitry, and after de-amplification and noise rejection, it will be given to the optical transmitter. Its cleaning is done, and then it is converted back to the optical form, and optical amplifiers are there along the length of the fiber. And on the receiver side we have the photo detector, amplifier, and signal restorer, the wave shaping circuit again, which will give the output similar to that of the electrical input on the transmitter side. And the adjacent figure shows the optical fiber communication principle, how the optical fiber communication is taking place. So that's it. Thank you very much.